So a sequence is a basically just numbers written in a specific order. What?
I thought it was the game sequence.
I don't know that.
You know?
No. So we got two kinds today. We got an arithmetic series or sequence. So this word goes way back to being a little kid. What does arithmetic mean? Math, right? And what's the simplest math that we learned?
2 plus 2.
Okay, so we learned what? Adding, right? So anytime that you hear the word arithmetic, you're going to think about adding. All right? So an arithmetic sequence is a sequence with a common difference and if we get technical here, what does a difference mean? Subtraction, right? So the easiest things that we did in math were either addition or subtraction. So we're going to find a common difference between any two consecutive terms. What does this word mean? Consecutive.
Like
If there were consecutive numbers in my list, they were what?
the same.
In a row without stopping.
Exactly right. So consecutive in this case means numbers that are back to back. So when we talk about this common difference, it has to be in consecutive numbers, the numbers that are back to back to each other. But don't fall into the specific definition of a difference. We could have addition or subtraction. So if my numbers are going up, we're going to add, and if my numbers are going down, we're going to essentially subtract. But we could really think about adding a negative, so we could think about adding all the time. Right? Now, a lot of times when you get into these arithmetic sequences in a higher level math, you'll have this common difference would be shown as a specific letter. So it would be like D is equal to, and the only reason they use D is because of the difference. Right? So here's what you got to remember though. Don't be fooled when you look at this sequence and you find a pattern, because Grace, I think, used that word pattern. It is kind of a pattern, so you might find a pattern, but it might not be necessarily an arithmetic pattern. So remember when we counted by multiples? That was like taking the multiples of 4 and saying 4, 8, 12. That would be a pattern, but we're not necessarily adding the same thing. Now in that case we were, but if we still find a pattern, it might not be that we're adding the exact same thing. It's got to be the exact same number every single time, or subtracting the exact same number, okay? So if I look at this one, 3, 7, 11, 15, is there a common difference between all of those? So again, when Miley said it's right back to back, we got to think about any of the two that are right back. You cannot take the 3 and the 15. And then remember, what does it mean if I put dot, dot, dot at the end? It goes on forever. So they're saying that this is going to happen all over. So my common difference, let's call that D again. My common difference would be a positive 4 because I'm going up 4. And then a lot of the times in your homework, they're going to ask you to find the next 3 terms. So what are my next 3 terms in my sequence?
19, 27.
Perfect. Okay? And we should say that this is an arithmetic one, because we're going to show you another one in just a second. So, those are the things that we would answer for our question. All right? So, let's look at a couple more. -5, -1, 3, 7, and 11. Now again, you could go and look at just the positive numbers. Some people don't like looking at the negatives because it confuses them. But again, when I'm talking about the common difference, I'm looking at consecutive numbers. So I always want to take the bigger one and subtract the smaller one. It doesn't matter what my answer comes in. It could be a negative, it could be a positive. But if you can't look at it and see, then I'm just going to take this number and subtract from this number and subtract it from this number, this one. And so obviously up here we can tell that from 3 to 7 and 7 to 11, we went up by how much? 4. But did we do that over here? Did I take -5? If I add 4 to -5, would I get -1?
Yes.
And if I take -1 plus 4, would I get 3?
Yes.
Okay, so did we add? Yes, we added 4 every single time. So again, I have arithmetic. My common difference was what? A positive 4. And then what are my next 3 values?
15, 19, 23.
Then we just did that one? Yeah. That was dumb. Okay. Next one. 0, 2, 6, 12, 20. ... So again, just because there's a pattern doesn't mean that it's an arithmetic sequence. So, is this consistent between the numbers? No. This one we went up what? 2, then what? 4. So is there a pattern? Yeah, essentially we could probably figure out what our next terms are, but it's not specifically an arithmetic sequence. So can we, what's the next number in the pattern? Why? Yeah, up by 2, and then this was 4, so it went up by 2 more. 6, 8, 10, then 12, then 14. But it's still not a consistent. So in this case right here, is this? We would just say no, it's not an arithmetic. And you don't even have to go on any further. Make sense?
So is there like another kind of sequence?
There's another kind. Yep. So then obviously, then the last kind that we could have is if it would go down. So we have 13 to 8 to 3 to -2. So again, is my pattern consistent?
Yes.
Yes. So am I adding or subtracting something to get my consistency?
Subtracting by 5.
So my D is -5, right? And we came to the conclusion that we're subtracting, so it's arithmetic. And then what's my next 3 terms?
-7, -12, and -17.
Agreed? Okay? Piece of cake, right? So, the first one was arithmetic involving adding and subtracting. My other one is a geometric sequence. And this, we probably are going to do what?
Multiplying by?
Yeah, so geometric is if I go up, we're going to think about multiplication. If I go down, we're going to think about division, or we can always think about multiplication in this case. Because isn't multiplying by a fraction basically the same thing as doing division? If I would say that I was going to divide by 2, or if I would say that I was going to multiply by 1/2, isn't that basically the same thing? Yeah, so you can think of it either way. But again, when you're doing this, we're always going to take, so this is, if you want to think about it in like mathematical terms, the term on the right divided by the term on the right, or sorry, the term on the left. Okay? And that's going to show me what my common. Now, when they talk about these things, we still want to try to find the common difference. But instead of calling it a common difference, now we're looking for a common ratio. Now that word might be a little different to you. You might not know exactly what a ratio is, and that's why they don't really introduce it yet. But a common ratio, we would call this, instead of D, we would call this R. So my R is going to be, and then, so you could say that you're going to have a fraction, or you can just say that you're going to divide by that common ratio. Same difference. So, these can be a little bit more confusing because some people look at them and they can't really decide, well, do I want to think about dividing? Do I want to think about multiplying? Do I want to think about fractions? Do I want to think? There's a lot of different things that I can do in this problem. So basically, maybe you try this and do the term on the right and divide it by the term on the left. So again, I'm thinking about my consecutive numbers, like Miley was talking about at the beginning, just like over here. Or you can just look at it and say, well, what did I do to the one term to get to the next term? And so on and so forth. I just have to make sure that that is consistent throughout the whole thing. Did I use the same number to multiply or divide by? Okay? Or I can actually do the division. So, can you see something here?
Multiply by 3.
Multiply by 3. So, again, if we multiply, we're going to say it's geometric. Because if I multiply or divide, it's geometric. If I add or subtract, it's arithmetic. My common ratio in this case would be the number what?
3.
So I'm going to multiply by 3. Or you could just say 3. And then what are my next terms?
80. Yeah. 81.
81. Okay. Next.
123. No.
243.
Times 3 more.
710.
720.
I was
You were way off.
I was 110 off.
You were way off. Now, what's the other thing that you got to really be careful of in this is if my common ratio is a negative number. Because remember, if I take a negative and multiply or divide by a positive, my answer is negative. But if I consistently use that negative, if I have a negative in my sequence and take it times a negative, then it turns into a positive. So 2 positives make a positive. 2 negatives make a positive. But if their signs are different, then it makes it negative. So it could be bought back and forth if my ratio is a negative. Okay? So, let's try it again. So again, between consecutive terms, did I add or subtract something or multiply or divide something consistently in this one? No, right? Because anytime that we have back-to-backs, probably doesn't work. So this one right here is just, no, can't do it. Okay?
So your answer no.
So my answer is no, it's not a sequence. So they're gonna ask you, is this a sequence? And then if it is, what kind it is? Let's do. So, what do you think? If I have 63 and I'm going down to 9, I divide it by 7. If I take 9 and divide it by 7, do I get 9 sevenths?
No.
If I take 9 and divide it by 7, do I get 9 sevenths?
Yeah.
Oh.
And then if I take 9 sevenths and divide it by 7, do I get 9 over 49? What do I have to do if I'm dividing it involves fractions? Keep, flip, change, right? So what's 9 sevenths times 1 over 7? So do I have a sequence? Yes. What kind is it? Geometric. And now you have to describe. How do you want to say my ratio? Divide by 7, or you could actually say that I'm multiplying by 1/7. 1/7, right? That's the same thing. If I take 1/7 times this, I still get that. I take 1/7 times that, I still get that. Now, the next one. This is the hard part. Now take and either divide by 7 or multiply 1/7 to this, and what do I get? 9 over, what's 49 times 7?
No, 343.
343? That's only the first one. Now we got 2 more though. 343 times 7. 1, 2, 0, 3, 2401. Did you not get 2401? Times 7?
Okay.
16,807?
Okay.
You're too slow.
I'm not,
He doesn't even have his paper out.
So there's my 3 terms. Now again, I made that one on the fly and it's not going to be that hard today. But it could be something like that, right? So again, all I wanted to show you is that you can either say it either way. Divided by 7 or multiplying by 1 over 7, exact same thing. Okay? Or you're going farther?
no, I'm saying remember, and I'm hoping it's right.
Questions? All right. That's it. Piece of cake or not?
Two indivisible.
And then don't forget quiz tomorrow.
I guess
We gotta get in here and get going. We probably won't correct the assignment until the end because it'll be a short period tomorrow too. Right? We get out of it.
You need to stop it.
And then